Hi everybody, today we're going to do a problem on Chatellier's principle, and we are given each of the equilibrium stressors listed, determine the effect it will have on the concentration of each listed reactant/product, indicate whether the equilibrium will shift left or right or have no change, and indicate whether the shift favors the reactants or the products, or again, no change. So what do we know about Chatellier's principle? Well, we know that when a chemical system at equilibrium is disturbed, the system shifts in a direction that minimizes that disturbance. And that can come from concentration, a change in concentration, or a change in volume or pressure, a change in temperature, or an addition of a catalyst. And to help make this easier, the professor gave you a chart that helps you identify more easily what happens when concentration shifts, volume, pressure, or the addition of a catalyst. So when you have an increase in concentration, the shift is going to be away from the affected substance, and that is because the excess concentration needs to be used up. Again, it's also the same with decreasing concentration, the opposite, towards the affected substance. That means it's going to produce more of the substance that is now lacking. When you have an increase in pressure or decrease in volume of a system, it's going to shift towards fewer moles of gas, and that's because it needs to relieve added pressure by decreasing that moles. And the opposite, with decrease in pressure, it's going to shift towards the moles of gas to make up for the loss of pressure by increasing the moles. And when you have an increase in temperature of a system, the shift is going to be away from the heat or energy, making it endothermic process favored, right? And that is because the added heat or energy must be used up. So when you have a decrease in temperature of a system, it's going to shift towards heat or energy, making it an exothermic process. And that is because it needs to produce more heat or energy that is now lacking. And when you have an addition of a catalyst, it's not going to have any shift because the rate of the forward and the reverse reaction are increased by the same amount. So we need to identify whether there's going to be a shift or no change for the following stresses. And something to know is that pure solids and liquids are not included in the equilibrium constant expression. So knowing that, we can already identify that we have two solids and that they are not going to be included in the shift, or whether it favors the reactants or products. So when you have CO3 added, there's going to be no change in any of these, again because it is a solid. The same will happen for CaO is added, also because it's a solid. So now we have CO2 is added. And this will be different because that is a gas and that is included in the equilibrium constant expression. So when we increase and we add the CO2, we're going to decrease the amount, the CO2, sorry. We're going to decrease this because we need to make this back into equilibrium. So that means it is going to shift to the left, and that will favor the reactants. The next one is going to be temp is decreased, And that means that this concentration of CO2 is also going to decrease, making this shift to the left in favor of the reactants. And this is also because the temperature here will help us determine whether it's decrease or increase. So when you decrease this, it's going to need to come back over here and shift to the left to help compensate and make that go back to equilibrium to make up for what you lost. So when a catalyst is added, as it said in the chart, there's going to be no change. Again, because the rate will be the same for the reactants and products that are left or right. Next we have CO2, the concentration of CO2 is decreased. That is going to make the concentration of CO2 increase. It will shift to the right, and it will favor the products. Again, because it needs to make this go back into equilibrium, when you decrease this, it needs to shift this way to help fill that gap that you lost. So when temperature is increased, it's going to be the opposite of when the temperature is decreased for the same reasons. It's going to increase. It will shift to the right, and it will favor the products. Next is CaO is removed, and we will have no change, right? Because this is a solid, and again, solids are not included in the equilibrium constant expression. Okay, thank you.